Hello everyone, so in this video I was thinking maybe we could do something a little bit more interesting, like a procedural table. So let's start with importing BPY and defining the variables that we're gonna need. We're gonna need a width, a height, a length, and maybe a thickness that we're gonna use for the legs of the table and maybe also for the base of the table. So let's do 0.1. Now that we've defined our variables, let's start by creating the base. So if you don't remember what the function for creating a cube is, you can just go ahead and create a cube, then look in the info tab and copy that command. But I know it, so it's bpy.ops.mesh.primitive cube add. So we need a location and a scale for this. We need to define them here. So location is gonna be a tuple and scale is gonna be a tuple. Okay? So for the location, it's gonna be in the center of the world, but in the z-axis, it needs to be at a certain height. So we're gonna do 0, 0, and height, which is the variable that we defined here. And for the scale, in the x-axis, it's gonna have the width, and in the y-axis, it's gonna have the length. In the z-axis, it's gonna have the thickness. All right, I hope that makes sense. So we're gonna do width, length, and thickness. So for this function, the location is gonna be location, and the scale is gonna be scale. So if we press run, we have a typo, so we're gonna fix that. And press run again, and we have the base of our table. Now for the legs, we're gonna do pretty much the same thing except with different locations and scales. So we're just gonna copy this. Let's comment our code. So this is the base of the table, and this is gonna be the first leg. Now for the location of the leg, we want it to be in the x-axis over here. So this is basically the length of the table divided by 2, all right? And in the y-axis, it's in the width of the table divided by 2. I hope that makes sense. If we take a look at the table, this is 0 and this is the length. So this distance is the length divided by 2, and this distance is the width divided by 2. All right, so if we want this distance, this is the length divided by 2, and this is the width divided by 2, and that will give us the location of this point here. Okay, width divided by 2 and length divided by 2. The z value, let's just have it at 0 for now, and then we're gonna figure out how to correct it. So let's do 0, and for the scale, it's gonna be a bit different because we have the leg of the table that has a thickness. So x and y are gonna have the same thickness for now, and a z value of height because we want the leg to be as high as the base of the table. So let's do height. Okay, so let's make sure we don't have any typos and press run. We have this, which is not quite what we were hoping for, because when a cube is added, it already has a size of 2, so that messes up the measurements. So let's just go back and fix the size. We add an argument for size equals 1. Same thing here. And press run. So we can see that the leg is added in the right place, but it doesn't have the right z value. Okay, so if we look here, we see that its center is here, but it needs to move upwards with a value of height divided by 2. Okay, so this is the height, this is where it starts, this is the half of the height. So we have another half of the height here. So for the location in the z-axis, we're gonna do height divided by 2. Okay? And let's see if that makes sense. So we're gonna delete everything and start over. And here we have it. We're gonna fix this little offset here, but this gives us at least something to start with. So this is great. Now we're gonna need to add the other legs. It shouldn't be that difficult because it's using the same idea. So for this one, it's gonna be the width divided by 2, the length divided by 2, and the width divided by 2, but this one is gonna be negative. Okay, so let's do the same thing. The location is gonna be width divided by 2 and length divided by 2, but the x is positive and the y is negative here. Okay, the scale is gonna be exactly the same. So let's remove everything and see what that does. Okay, it created it, so that's interesting. Now for the others, they are basically the same values, but they are flipped. So let's do one by one. So for the one that's here, we have a negative x value and a positive y value. So let's do that. It's a positive y value and a negative x value. This is the x, so it should be negative, and this is the y, so it should be positive. Okay, one more time. There we have it. Okay, for the last one, we have a negative y value and a negative x value, so it should look something like this. We delete everything, we should have this. Okay, now this is interesting and all, but it's not better than doing it by hand. If anything, it's slower than doing it by hand. So let's try to do something a little bit more procedural, even though we're gonna move into more advanced procedural stuff as we go along. So let's turn this into a function. So if you're familiar with Python, you know how to make a function. So let's call this make table. Okay, and let's indent all of this. This make table is gonna take a width, a height, a thickness, and a length. Okay, so when the program starts, if we delete all of this, if we press run, nothing is gonna happen because we just defined the function and we didn't call it. So let's call this function. So I'm just gonna paste these values, and I'm gonna call this make table with these values. Okay, now when I press run, it's gonna give us an error because I made a typo. But if I press run, it should create the table. What I want to do now is I want to delete everything automatically without doing it manually. So I'll just take the function for deleting everything from the info tab, and I'm gonna add it before making the table. Okay, but in order to delete what's selected, we need to select something first. So let's see what the function is for selecting everything. This is it. Okay, so each time the script is run, we need to select everything, delete everything, and then make a table. Okay, all right. So this way, when I press run, it's not gonna create a table on top of that. It's just gonna delete everything and start from scratch. So if I change the width and press run, it's gonna change it right here. If I change the height, same thing. And now we have a procedural table that adapts to our settings in real time, kinda. So I'll just change the thickness. All right. We can change the length to something like 5. And it adapts in real time. So if we had like a panel, you would see this as a slider that we can change, and it's gonna change the output in real time. We're gonna do that in later videos, but for now, if you understood all this, then you should be good to go. If not, please rewind the video and start from scratch, because this is very important to get a hold of before moving into more advanced topics. And I'll see you in the next video.